My roots are in insurance. I've been an actuary for a long, long time. I became an actuary in the mid-90s. But I'm going to talk about AI from kind of a very general perspective, but I want to just give you a little bit about my background so you can see how it's kind of rooted in the insurance industry. So I started my career as an actuary in the mid-90s. I worked at Allstate Insurance Company, just doing kind of standard issue rate filing kind of stuff. And I didn't really want to be an actuary. I wanted to do something which I didn't even have a word for back then. I wanted to be a data scientist, but that phrase didn't exist back then. But I sort of lucked out and I got a rotation to Allstate's Research Center, and I built Allstate's first credit scoring model. So that got me thinking about algorithms and big data and fairness and the sort of like the behavioral quality of data, how past behaviors are picked up in data, then that data could be used to predict future behaviors. That's why credit scoring works so well. And just the whole idea of automating decisions, right? Like once upon a time, making loan offers or making insurance policy contract offers was something that humans did, underwriters did, but then it was done by machines. So today we would call that an early example of artificial intelligence. I never would have called it that back then, but that's the way people are talking today. So I did that for a couple of years, and then for personal reasons, I took a job at Deloitte and Touche, which later Deloitte Consulting. And again, I didn't really know where that was going to take me, but I was interviewing for a job, basically doing the same thing from a technical perspective, building these kind of like predictive models, but for commercial insurance instead of personal insurance. And my colleagues were bragging about the fact that they use neural networks to do this. Neural networks are kind of the forerunner of what today people call deep learning. And honestly, I was telling my colleagues at the Allstate Research Center about this, and they were all laughing about it. And I just thought this is going to be a joke. This is just complete snake oil. There's no way this is going to work. Because for one thing, neural nets wouldn't make any sense for this kind of data. The data for commercial insurance, as you can imagine, is much thinner, right? For personal insurance, if you're Allstate, you got a lot of policies. And cars are cars are cars. There'll be some differences, but there's a lot of kind of homogeneity. With commercial insurance, you've got fewer policies to insure, so less data. And the policies have less in common. You might have a flower shop that you're selling workers' comp to, or you might have like a huge construction company or a chain of department stores. What do they really have in common? So I thought to myself, how can you actually do what we're doing at Allstate for commercial insurance or for credit scoring and do that for commercial insurance? And then neural nets, really? That's crazy. Well, I was missing a couple of things. I was actually right about the neural net thing. That was kind of silly. We stopped doing it after I arrived. But what I didn't understand at the time is that we weren't using these algorithms to automate decisions. We were using them to help people make better decisions, okay? And again, it took me kind of a while to wrap my head around this, but like the actual success of what we did at Allstate for credit scoring, to an extent, really turned on like the quality of the data and also, our ability to do a good job of analyzing the data. We made some mistakes along the way. We caught some of them, you know what I mean? But there are a lot of pitfalls in doing any kind of data analysis. With Deloitte, it took me a while to kind of understand the fact that the success of our service offering wasn't just the algorithm. It was the way the algorithm was woven into human work processes, okay? So that gave me a point of view that I started developing. And I started getting involved in psychology and human factors and like the behavior of people using these algorithms that's more or less obsessed me for about 20 years at this point, or maybe more. I won't tell the whole story, but that's kind of where I'm going with this. Like right now, fast forward to today, and I never would have thought I'd be up here on the stage talking about artificial intelligence. I had, AI books, on my shelf when I was a geeky high school student, and I thought of that as being like, we're trying to build human-like cognition in machine form. And right now there's a lot of confusion about AI because it really means two things. On the one hand, there are these people in Silicon Valley that want to build human-like intelligences in machine form, and a lot of them think they're going to get there. But on the other hand, when people like Scott Sobel asked me to come up here and talk about artificial intelligence, it's practical AI, kind of like what I was doing at Allstate 20, 25 years ago. So those two meanings, and that confuses people a lot, okay? All right, so let's get started. So there's a lot of confusion around AI. I'm going to give you two contradictory quotes that I agree with both of them, even though they're contradictory. The first is that AI is the new electricity. Okay, so this is Andrew Ng. He's one of the deep learning, machine learning AI pioneers in Silicon Valley. And what he means by that is that AI is what economists call a general purpose technology. That's like previous general purpose technologies were like the printing press, the steam engine, the mainframe computer, electricity. These are technologies that have, long-lasting, wide-ranging effects on not just economies, but societal arrangements. Okay, so it's like a really big deal. And I actually kind of think that's right. And there's that ambiguity there. Some people who say AI is the new electricity, they think we're creating human-like intelligence in machine form. Others just say, no, these algorithms are really important. They're just like very valuable just for economic reasons. Okay, so there's a lot of it. There's ambiguity in there. The second quote, which kind of contradicts the first, which is also correct, is that AI is an ideology, not a technology. Okay, that's polemical, but so Jaron Lanier, who said that, he's a researcher at Microsoft Research. He's one of the pioneers of virtual reality. And what he means by that is the technology is kind of like a more advanced version of what I was doing 20 years ago at the Allstate Research Center. Big data, machine learning, these kind of algorithms that enable us to extract patterns from big data. And those can do really powerful things. And it's gotten to the point where all of us are surprised at how powerful these things have become. If any of you have used, just show of hands, how many people have used ChatGPT in their okay. I'm surprised it's not higher, actually. I'm using ChatGPT now, and I'm amazed at how effective it is. It's incredible. That's deep learning, which is like a more advanced version of the same neural nets that we were using at Deloitte when I started 20-odd years ago. It's the exact same process, just the data is incredibly rich. We're training these neural net models on the entire internet. So they can do really surprising things. So the technology is big data and sort of like pattern recognition algorithms that computer science has developed. The ideology, AI, is again going back to this old idea that keeps coming back and won't die, that we're creating a new form of life. We're creating kind of like machine-like intelligence in human form. So the ideology is when people say, this is actually the mission statement of OpenAI, one of the most valuable companies in the world. OpenAI's mission is to ensure that artificial general intelligence, AGI, by which we mean highly autonomous systems that outperform humans at most economically valuable work, benefits all of humanity. So they really think they're going to build algorithms that are so smart that they can put all of us out of work. That's literally their corporate mission statement. DeepMind's mission is to solve intelligence and use that to solve everything else. The DeepMind co-founder Mustafa Suleyman warns that AI is a fundamentally labor-replacing tool over the long term. And this is like years ago. Google said it's closing out on human-like artificial intelligence. The game is over. We're almost there. These guys have said over and over again, we know how to do this. It's just a matter of time before we put all of you guys out of work. We're creating something that's going to be smarter than all of us put together. And even Sam Altman, before ChatGPT was released a couple of weeks ago, he was saying this is going to be like having a room full of PhDs in your pocket. So that's the ideology wrapped around the technology. Now, the thing about like loose language is it makes it easy to say dumb things. Okay, that's something George Orwell said a long time ago. So, Anthropic warns that fully AI employees a year away. A Google engineer, this is, I think in 2021, he claimed that his AI chatbot was sentient. People in the New York Times, journalists are asking, if AI systems become conscious, should they have human rights? A book co-authored by Henry Kissinger, of all people, and Eric Schmidt, The Advent of AI obliges us to confront whether there's a form of logic that humans have not achieved or cannot achieve, exploring aspects of reality we've never known or may never directly know, whatever that means. And this is just last week. I didn't have time to put this in the slides because I already finalized the slides. Tom Friedman wrote in the New York Times, we have not merely birthed a new tool, but a new species, a super intelligent machine. So this is the way that a lot of people are talking about it. And a lot of people think there's an AI bubble coming right now, kind of akin to the dot-com bubble of the late 90s, because a lot of people with a lot of money take this stuff really seriously, okay? So that's the ideology wrapped around the technology. Oh, okay, I'm gonna have to squint here. All right, but there's a better way of thinking about this stuff. Now, I think that a lot of smart people are saying really dumb things because smart people can say dumb things when they have like bad ideology and bad language. Well, there's a great quote from Alan Kay, which is the opposite. He says, a changed perspective is worth 80 IQ points. Alan Kay, in case you don't know who he is, he was the research director at Xerox PARC, the Palo Alto Research Center. He was there when Steve Jobs famously visited Xerox PARC and got all those ideas for Apple computers. That's why Xerox didn't make a lot of money, but Apple did. He basically he built the first modern graphical user interface. So I think that there's something similar going on now. I think that one way of thinking about that Alan Kay, Steve Jobs meeting all those years ago was that most people in Silicon Valley at the time were thinking of computers as technological artifacts that engineers could use, and it'll be good for certain business problems. They didn't think the PC would take off. Steve Jobs and Alan Kay both had a different vision. They said this is really like a cognitive partner. It's something that we can design for humans to work with, and it will make humans smarter. And that vision eventually prevailed, although at the time it was just a couple of like random hippies like Steve Jobs and Alan Kay. But that's eventually what took off. I think the same thing is going to happen with artificial intelligence, and I'd like to kind of like articulate that perspective now. So I think a change of perspective about artificial intelligence will be worth 80 IQ points, not just because it'll make Tom Friedman and those executives sound smarter and Henry Kissinger sound smarter, but also it'll make the technology smarter. It'll give us 80 IQ points in our systems, because right now our systems are kind of dumb. They can do really impressive, surprisingly good things, but they're still kind of dumb. So OpenAI, if you use OpenAI ChatGPT, it's really, really helpful. It can do things that no human could do. It can copy edit something for you in a way no editor could do. It's incredible. But at the same time, it has zero common sense. It has less common sense than your 5-year-old son. So it's really brilliant in some ways and kind of dumb in other ways. Just like we're really dumb in a lot of ways, but really smart in other ways. But it turns out the ways in which we're smart and dumb and the ways computers are smart and dumb are like two puzzle pieces that fit together. And we haven't figured out how to fit those puzzle pieces together yet. And fitting those puzzle pieces, that's the future of AI. That's the change in perspective that I want to talk about. So it's collective intelligence. It's the idea of, collective intelligence is sort of like a ghost that you see all around you when you're on the job. If you're ever in a team of people and you're working together and you have kind of complementary skills and you talk to each other and share ideas, and the team can accomplish something that no one of the people on the team could accomplish, well, in the same way that I can measure somebody's, or a psychometrician can measure somebody's IQ, people have actually measured the IQ of teams. They call it factor C for collective. There's something called collective intelligence of teams. And by the way, there aren't that many women in the room, but there are some. Teams that have more women are smarter than teams with no women. And it's not a diversity thing. It's not 50-50 is the smartest. Teams with all women are smarter than teams with 50% women. But that may be partly because of the fact that women have better social perception than men. Women are better at reading facial expressions. So there's somebody on the team who really knows something and wants to say something. People with better social perception are better at pulling that out. So those are the kinds of things that are more determinative of collective intelligence than just raw IQ. And again, people are making this mistake. If we have this kind of raw IQ machine that will add to the teams, it'll make these teams smarter. Well, no, you can get a team of a lot of really smart people together, and if they don't really talk to each other, they'll do something colossally stupid. That's called groupthink, and it happens in business all the time. So if we don't have the right kind of team design, we'll get human-machine groupthink and human-machine stupidity rather than human-machine collective intelligence. I can actually give you an example of this. It's getting pretty abstract from my experience. So going back to my days at Deloitte, remember I said we were building these predictive models to help commercial insurance underwriters better price and select risks, okay? Now, for simple risks, they'd automate it, like a small commercial package policy or something like that. But for most risks, the underwriter would kind of get the score and they'd process it along with all the other stuff they're seeing. And what we found was that enabled them to systematically make better decisions. Again, I was surprised on the job because I was just building the model. I didn't have the overall perspective of what we were doing. But because we wove it into the work processes appropriately, our clients would actually make a lot of money. And so we were in a really good position. We were the only people doing this for a long time. And so we were just like, people kept calling us because our clients they saved a lot of money by implementing these models. But after a year or two, we got a call from a smaller client that didn't have a lot of data. It was a workers' comp carrier for a small state. And they said, we'd like you to build one of these models. And we debated internally whether we should even do this thing, because we weren't sure there'd be enough data to support a rich enough or a robust enough model. So we said, look, we'll do it for you, but no guarantees. We'll do our best, okay? And they said, you just give us the algorithm, we'll implement it, okay? So we did the best job we could. We built this algorithm, and we got a call from them 6 months later, and they said, we were surprised. They said, you guys should feel really good about yourself. This algorithm was just as predictive out of sample as we hoped it would be. And we were actually pleasantly surprised by how well the model was working out of sample. But then the client said, but we lost money with it. And the reason, remember that we just gave them the algorithm and they ran with it. What do you think happened? The underwriters took the algorithm and they gave discounts to good risks, but they wouldn't commensurately surcharge bad risks. So they collected less revenue with an algorithm they validated was good. Now that's an example of you had some people doing something that was pretty good. The algorithm has the potential to raise their performance, but by adopting it a bad way, it actually did something really, really bad, okay? I was regaling an audience with this fascinating story. I'm going to skip ahead. In Atlanta, I was teaching a data science boot camp to a bunch of actuaries in Atlanta. And after I I told the story at the end of the day because we were kind of getting tired, and thought it'd be kind of a fun story to tell about, the kind of like they lost money with a good algorithm kind of thing. Because I was teaching them how to build these algorithms. I was trying to give them this perspective that all these other factors are really important. The kind of human workflow factors are very important. So I called a cab or an Uber to get to Midtown to go to a restaurant. And the cab driver, it was just a straight shot up Peachtree Street to get from the Deloitte office to the restaurant. But the cab driver, who's a local, got lost along the way because he was following the signals from a GPS app that were distorted by all the high-rise buildings in Atlanta. And I realized this is just like what I was talking about with the underwriters. And it occurred to me that we should have a word called artificial stupidity instead of artificial intelligence. So artificial intelligence, all the Silicon Valley guys think they're building a new life form where artificial intelligence is in the algorithm. But in reality, remember those ghosts I was talking about? In reality, artificial intelligence is at the level of the human algorithm system. Kind of like the collective intelligence is at the level of the team, if you guys are working on something and you're working well together, okay? But if you don't get that team right, if you introduce somebody to the team who's kind of a blowhard, and usually it's a he, went to a good school, and is kind of full of himself, and maybe the leaders put this person on a pedestal, guess what'll happen? Very often the team will do something really, really dumb, because the people he's working with, again, usually he, they'll know something he doesn't know, but he's too much of a blowhard to listen. And these computers, I once gave a talk at a guest lecture for a computer science professor, and as soon as I told this, he said, he leapt up and said, "That's exactly right. These algorithms are like, alpha males. They don't have any social perception at all." And so that's what gave me the idea that artificial stupidity is kind of a thing. But I'm getting ahead of myself. Let me just go back a little bit. I'll go back to artificial stupidity. But since those early experiences with these algorithms, I learned that what I experience with these algorithms is a very small example of something that computer scientists have known a long time. Some people think this is the biggest lesson in the history of AI since the 50s. It's a headline that keeps getting buried, which is that the hard things are easy and the easy things are hard. So back when people, like in the late 50s, early 60s, started researching AI, I'm talking about people like Herbert Simon, who won the Nobel Prize, they all thought back then that if you could have a logic solver or a computer that could prove theorems or play chess and beat the humans at playing chess, the game would be over and we'd have human-like AI, because chess is really hard. Like all this other stuff, like seeing this and picking it up, that's really easy. A little kid can do that, right? That should be really easy. Well, it turns out that playing chess and proving theorems are the easy things for computers to do, but getting a robot to kind of pick this up and move some junk out of the way and fix your garbage disposal, this is nowhere in sight. That's really hard. So that's called the AI paradox. Okay, the things that are easy for us are hard for computers, and the things that are hard for computers are easy for us. And that's true of ChatGPT. It's very hard for us to have like all the world's information at your fingertips and think of like a great way to rephrase a sentence. I get stuck on this all the time when I'm writing, and it's great just to put a paragraph into ChatGPT, and I'm like, it would have taken me a day to figure that out, but I got it instantly. It's fantastic. But it could never think of like what is the right thing to write in the first place. That's the part that's easy for me, is coming up with the ideas, right? And actually guiding the tool. So think of ChatGPT as a little bit like GPS. GPS guides you through Atlanta. It guides me through Los Angeles when I'm at home. Well, OpenAI is like a navigator that helps you kind of like navigate through this world of past discoveries and inventions and ideas. Kind of like going to a library and using the card catalog. This is like a modern example. It's sort of like active libraries. All right. So that's the idea. Like, so we're good at sort of common sense reasoning, but we have biases. Like if you've ever seen the movie Moneyball, that was a lot like insurance underwriting, where the baseball scouts they're smart people and they're trained, and you can't dispense with them. You can't replace a baseball scout with an algorithm. But at the same time, they kind of go off on these tangents. They kind of have these wild stories about why this baseball player would be a good risk or a good player or a bad player. But a simple algorithm would help them make the decisions better. And that's true in actuarial science and underwriting. It's true in HR, like Moneyball. It's true in medical diagnosis. It's better at predicting which wine is going to be a good vintage of wine. And in domain after domain after domain, because we have these kind of cognitive biases, algorithms don't have cognitive biases, and they can kind of help us out, all right? Or for self-driving cars, we're good at handling uncertain, novel situations that have never been seen before, where a computer would choke. But we get bored, we get road rage. So like a computer might be better than us on a highway, but we might be better than the computer in bad weather or in a very complicated city center, right? So across the board, we're better at thinking of these things as complements rather than substitutes, okay? So that's called the AI paradox. I can give you a very tangible example. I think my underwriting example is pretty good, but I'll give you like a really memorable example of human-computer collective intelligence where you just can't argue that this is like a real phenomenon, even though it's kind of ghostly. And do you remember in the late 90s, I was still studying for my actuarial exams, and I remember reading these headlines. Garry Kasparov, who's in the news now, again, he was competing against IBM's Deep Blue computer in a big chess championship. And people forget this, he actually beat IBM once, but then he's up for a rematch and they improved the computer or something, and he lost to Deep Blue. It was like a really big deal, okay? And he was crushed by this, you know, it was like this kind of man-machine kind of thing. But then after he lost to Deep Blue, he did something interesting. He invented this game of chess called advanced chess, where instead of just Kasparov playing another grandmaster, it could be Kasparov using a laptop, playing another grandmaster using a laptop. And this became a thing. And about 5 years after this, or 8 years after this, there was a global competition of this kind of advanced chess. It was called freestyle chess. And it was all around the world, and anybody could enter. And it was like the top chess players in the world were using the top computers in the world, competing against each other. But there was a upset victory, and these two guys won, Zach and Steven from New Hampshire, and they were just using 3 ordinary laptops, each equipped with a different chess program. So 2 amateur chess players with 3 of the most basic chess programs, and they beat the grandmasters using the supercomputers, right? Think about that. Where was the intelligence in that story? Computer 1, computer 2, computer 3, Zach, Steven? No, the intelligence was at the level of the system. And Kasparov did this great comment. I can barely see this, but he said, he basically said their skill at coaching their computers, they basically use the computers to look ahead a few positions. And he said that better process of working together was able to outperform chess grandmasters using the best computers, but they had an inferior process of working together. So he nailed it. That's called Kasparov's law, that the process of the human working with the machine together, that's what creates this human-computer collective intelligence. And here's the implication that Sam Altman and the Silicon Valley guys don't want to hear. That's not a computer science problem. That's an organizational design problem. It's a behavioral economics problem. It's a psychology problem. It's a human factors problem. It's a little bit like Alan Kay inventing the GUI and Steve Jobs saying, no, we need a mouse that that a little kid can use. That's what's going to make these computers, that's what's going to make the human computer system smart, not the quality of the microchip. So it wasn't Wozniak, it was Jobs, it was the design layer. Okay, all right. Some more artificial stupidity. This screen is kind of broken, so I can't really see everything, but there are a lot of examples of this. Oh yeah, after the Atlanta episode, a couple of years later, I read an article, I just came across this. There's something called death by GPS. So that thing I observed in Atlanta, that's actually a real phenomenon. People actually die or have near-death experiences driving to the middle of Death Valley in the summer or across snowy mountain passes. A couple years ago, I was giving this lecture in a behavioral economics class, and the most recent story I could hear was a guy who is very tragic. He got killed by driving over a collapsed bridge in North Carolina. And then this one from this past spring, the same thing happened in India, in Uttar Pradesh. So it's not like it happens all the time, but it's a real thing. It's a systematic thing. And when there's a systematic failure like this, when humans and devices are involved, you don't want to blame it on the devices, on the humans. It's not human error. It's a failure of design because it happens systematically. Okay, you've got to kind of make the system conform to human behavioral biases, not expect that human behavioral biases can magically go away. Okay, so that's death by GPS. There's also something I call, instead of death by GPS, how about disgrace by GPT? So after GPT was unleashed at the end of 2022, beginning of 2023, you start to see these stories about how lawyers would use ChatGPT to create legal briefs, and GPT would hallucinate legal citations. And there are a couple of really dramatic stories, and the lawyers were censured for this. But it turns out there's a database keeping track of this, and there are over 200 cases right now. So just like death by GPS, it's a systematic thing. And my favorite example, this is not being recorded, well, maybe it is being recorded, but I did a fellowship at Stanford a couple years ago, and I remember coming across this guy this happened to. He's a communication professor who specializes in AI misinformation. And he was doing work on the side. He was getting paid $600 an hour for a court in Minnesota, kind of writing some kind of a brief about computer misinformation. He used ChatGPT to help him write his brief, and it had hallucinated citations, so he was censured by the judge. So the point is that this can happen even to the smartest, most sophisticated person. A professor at Stanford who specializes in misinformation, he used the computer to create misinformation, and the judge threw out his work. So that's disgraced by GPT. It's the same phenomenon. So like that little thing that I noticed 20 years ago, it's all around us. Now that AI and algorithms are ubiquitous, that phenomenon of artificial stupidity is also ubiquitous because the design layer is an afterthought. You know, again, going back to my experience at Deloitte, there were other people that were trying to compete against us in this commercial insurance space. And again, before I understood this principle about the human-machine integration layer, I was the data scientist. I was the guy responsible for building these algorithms. And all of a sudden, there'd be some new guy with like, he had a Russian last name, and he had a PhD and blah, 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 and he did support vector machines, and he would like go on and on about how support vector machines are obviously the right solution. It's much better than these generalized linear models, blah, blah, blah. But again, these boutique companies, they claim to be selling better products at a cheaper rate than Deloitte did. But the reason why Deloitte was expensive is because we did business implementation. And the business implementation is what I'm calling this design layer, implicitly. You know, it was like we were kind of muddling through it, we were kind of making up as we went along, but we actually worked, in parallel with me building the algorithm, we had other people working with the people on the receiving end of it saying, what are you going to do differently? How is your workflow going to change with this? And that was a big part of the success. Okay, I think I'm making the point. Again, there are a lot of these things. Like people are, like, there's a case of a guy who stopped eating salt, and so he got a disease because ChatGPT told him to. So really bad things can happen. Another example, this is a bit more close to home. Detroit, police officers or detectives in Detroit arrested the wrong guy for a theft at the Shinola flagship store in Detroit, this kind of hipster store. He was caught. The thief was caught on video. They used kind of a facial recognition algorithm to kind of like match the face in the video to a database of faces, and they just kind of ran with the algorithm's indication. They basically held up the wrong guy. The guy they arrested held up a picture of the true thief against his own face, and it was obviously a different person. And the police officer said, "Ooh, I guess the computer made a mistake." But again, that's like death by GPS. Now, here's a little hint of where I'm going, kind of analogous to Alan Kay's graphical user interface of the mouse, like this kind of human factor kind of thing. What if instead of just giving the police officers the best match, you embedded that match in a lineup of 3 or 4 other people, one of whom was Christopher Walken? And it's obviously wrong. The officer has to be engaged. The officer would actually have to think. So rather than arresting the wrong guy and saying, do we really look alike? They would have been forced. So that would be so behavioral economists call that choice architecture, right? Just adding a little bit of human factor design, a little bit of design to the system will create smarter results. By analogy with a self-driving car. So that's an example, by the way, of how actually watering down the algorithm, kind of analogous to like giving that blowhard who joined the team a little bit of humility, can lead to a smarter collective intelligence. With a self-driving car, another example that really caught my, I led by the way, a couple years ago, I had a fellowship at Stanford, and I was given a grant to lead kind of a study group on this idea. So it's not just me saying this. I was able to develop these ideas with this really smart team of academics. And the last day, there's a human-computer interaction professor from Cornell Tech, and she gave a great example of what she was experimenting with, which was in a semi-autonomous car. Again, full self-driving, not really, right? But they're very helpful. But how do you get that human-machine collaboration right? And she said, if you just like give the car a little bit of swerve or a little bit of weave within the lane, just so it kind of vaguely freaks the human out, they will keep their hands on the wheel. And I thought that was really devious and kind of brilliant. But that's anticipating rather than just saying, right now the mindset is, you've got to pay attention, keep your hands on the wheel, because this can fail at any moment, and when it fails, snap to attention right away. And that's like, if we were all Mr. Spock walking around, sure, that would work. But we're all Homer Simpson. Nobody will do that. Literally nobody, right? But if you kind of take into account actual human psychology, we have like bounded attention, we get bored, we get road rage, like whatever, then you'll design around that. And her little swerve, that's an example of that. So that became one of our favorite takeaway examples. And by the way, another kind of interesting example, this is from, oh, sorry guys. Clickers give me a hard time. Yeah, Nicholas Christakis, he did a study where he showed that giving people kind of like driver assist technology actually kind of like crowded out more ethical behavior behind the wheel. People would play chicken with each other more often. So it's not just like, so in the case of artificial stupidity, very often it's like, well, you stop paying attention, or you will, stop eating salt because the computer told you so. This is like, it'll actually make you act less moral. I'm gonna give an example in a couple of cases of one of my projects at Deloitte, where I use behavioral economics and data and machine learning to make people more moral in a insurance context. So I'll tell you that in just a minute. So anyway, the bottom line here, so the guy who kind of wrote the book on human-centered design is Don Norman. There's a famous book called The Design of Everyday Things. I wish I had a copy of it. I forgot to put a picture of the picture on my slide. But he basically said, I can't read my own slide. He said, we must design for the way people behave, not for how we wish them to behave, right? So that's, so he wrote this decades ago, but that self-driving car example is just like yet another example of how profound his point is. Don Norman is trained as a psychologist. His book was originally called The Psychology of Everyday Things, but he renamed it The Design of Everyday Things. But that's basically the idea. You want to kind of build systems and tools and technologies, personal computers, AI technologies, whatever they are, that go with a grain of human psychology rather than ignore human psychology. His famous example is what's called the Norman door. You can actually look this up. There's a Wikipedia page on the Norman door also. I'm sure this has never happened to any of you, but it's happened to me once or twice, right? There's a pull handle, it says push, you pull it, you feel like an idiot. But Don Norman would say, no, the designer of the door should feel like an idiot, because this happens all the time. Richard Thaler, the guy who basically invented behavioral economics, he was inspired by Don Norman when he wrote the book Nudge. Nudge is basically Don Norman applied to choice environments. And I read his memoirs, and he said that at the University of Chicago, he would teach Nudge and teach choice architecture, and he would give that example of the Norman door, right, where you have to push to get out, but you pull it, because there's like this, it's called an affordance. So thinking fast, you say, oh, door, pull. Thinking slow is you read the sign. But most of our mental operations are thinking fast. So Richard Thaler explained this, and somebody was trying to sneak out to, leave class early, and they pulled the Norman door and made a big catastrophe, and the whole class burst out laughing. So even after you hear about it, you'll still do it. But the opposite of the Norman door is the Mac, or the personal computer. Remember Steve Jobs and Alan Kay? And like that's an example that my 86-year-old mother could start using without an instruction manual, or the little kid could start using. So that's a really sophisticated technology as opposed to a door. But because it was designed to go with the grain of human psychology, a little kid can start using it. It's kind of magical, actually, right? So bad design can create artificial stupidity. Good design can create one of the most valuable companies in the world. So there's actually a real business case for this too, okay? And that was Steve Jobs' idea. So Steve Jobs said that computers are bicycles for the mind. He had this great analogy. He said that if you look at the fastest species on the planet, humans are sort of middling. Like we're much slower than the condor. But a condor can't invent a bicycle. A human can invent a bicycle. And a human on a bicycle is actually faster than a condor. So we can build these computers that'll make us smarter. So yes, this new species, these new superintelligence are being invented, but at the level of the human-machine system. Humans are integral to it. So that's I think, how we should think about human-centered AI. I was asked to speak on human-centered AI, and that's kind of my answer. That's how to think about human-centered AI. I think it's a little bit more nuanced and a little bit deeper than just like AI that's good for us or AI that's ethical, which is the way most people talk about it. And actually, the guy Steve Jobs, made a lot of money off the mouse. The guy that invented the mouse was a guy named Doug Engelbart, and he wrote a whole manifesto on this. And he basically said that we should use technology not to replace humans, but to expand our capabilities. Okay. All right. So I'll give a couple of more positive examples of this in action. Okay. And because again, even though there's a lot of artificial stupidity and people aren't paying attention to it, on the margins, there are people doing this kind of stuff. It's just not a fully fledged discipline yet. It's not something people have the language to talk about. But here's an example from my own work from about 10 years ago. Some of my colleagues sold a fraud detection project to the New Mexico Department of Workforce Solutions, I think. They basically wanted to build an unemployment insurance fraud detection model. The idea is like, suppose somebody loses their job and they're collecting unemployment insurance benefits. And maybe they're working, they're mowing lawns or driving Uber on the side. They're supposed to report every week how much money they earned last week on some kind of a web portal, okay? Now, obviously, like the more you report, the less you collect. So there's this tendency for people to kind of like fudge it a little bit, maybe like, downplay how much they report. So they hired us to build an algorithm to flag people in real time who are, kind of misreporting their earnings. And my colleagues, I was down on the sales team, and it's a good thing, because if I was on the sales team, we probably wouldn't have sold it. This is a case where like knowing a little bit too much can actually make you a bad salesperson. My colleagues, my technical colleague called me and said, look, this is the project we sold. how are we going to do this? My first reaction was, it's not going to work. It doesn't matter how powerful your algorithm is. There's something called the false positive paradox. I mean, you experience this when you go through a metal detector at an airport, right? If you want to make the algorithm really sensitive and pick up all the potential terrorists or the people with weapons, it won't be very specific. It'll flag a lot of people, who just have keys in their pockets, right? And there'll be a lot of false positives because the overall base rate of fraud or the base rate of terrorism is very low. So it's Bayes' theorem. If the base rate is low, you're going to get a lot of false positives. So if we sold this project and built this algorithm to automate these decisions and automatically withhold benefits, we'd be doing the wrong thing the majority of the time. In addition to kind of withholding benefits from the people actually cheating, we'd be withholding benefits most of the time from people. Does that make sense what I just said? Okay, this is called the false positive paradox. This is the value of data science, by the way, not just running algorithms. People think that way, but all right, that's a side comment. But then it occurred to me that there was something we could do with this. There's a way we could salvage this project. And we got all excited about it. I said, let's build the algorithm. But I call this the last mile problem. The algorithm is just going to do the algorithm thing. It's just going to give you an indication. Fraudster, non-fraudster. Probably 10%, probably 30% of this person is collecting benefits improperly. What you do with that outcome is up to you. That's, again, the business implementation layer, right? So in our classic underwriting models, we would give that output to the underwriter, and they would make their own judgment call. In Moneyball, the baseball scout would get the algorithms, Jonah Hill's algorithms output, and they'd make a hiring decision. Well, in this case, you can't just give the output to a fraud investigator because there's just too many cases. You still have to automate it in some way. So what I suggested was there's this kind of like result from behavioral economics that fraudsters are not like identifying cats and dogs on the internet, right? You can use deep learning and image recognition to say, this is an image of a cat, this is an image of a dog. With fraud, it's a little bit different. It's not like, I'm honest and Scott is dishonest, although in fact that's the case. No, I'm kidding. No, it's the case we're all sort of like this mixture of honest and dishonest, right? It's like if I'm living in a country where the social norm is not to pay the taxes, I'll try to cheat on my taxes. Whereas if I live in a country where the social norm is everybody pays their taxes, I will probably pay my taxes. Not universally, but just in general. The degree of our moral behavior is not just the fact of our moral qualities, but the environment we find ourselves in. And the whole idea of choice architecture is you can if you change the environment, it changes people's behaviors, right? So there's this famous example from Nudge where if you're sending a letter to people saying, hey, please pay your taxes on time, they will read the letter and they'll just throw it out and ignore it. But if the letter says, did you know that 90% of your neighbors in Kansas City pay their taxes on time? Then you're like, if I don't pay my taxes on time, I'm the weird person. That was actually originally used to get people to use a little bit less power, use a little bit less water. So social norms are what really drive behavior. Or why do you leave a tip at a restaurant? That's just what grown-up people do. They leave tips in restaurants. It makes you economically worse off, but you do it, okay? That's why it's called behavioral economics. It's not because of economics incentives. It's just like all these psychological factors. So we're thinking if we can kind of use these principles, maybe we can get people to be a little bit more honest. So what we did was we used the algorithm. Instead of just using the algorithm to automatically withhold benefits, we would automatically give them a little pop-up message saying, did you know, if you're beyond a certain threshold, did you know that 90% of your neighbors in Bernalillo County report their earnings accurately? And what we A/B tested this the same way that Amazon will A/B test a website. And what we found was that this decreased improper payments by about 50%, right? And it's just like a little message that you could ignore, okay? So that's the power of thinking in terms of human psychology and human factors when you're implementing these algorithms. So Nicholas Christakis was saying, these guidance, these kind of driver assist algorithms make people less ethical behind the wheel. But here's an example where if you do it in the right way and you think about it really carefully, it could actually make people a little bit more ethical. So the difference is not the quality of the algorithm or how accurate the algorithm is, but the design layer you wrap around the algorithm. I'm almost done. I'll just give a couple more examples, and then I'll shut up. Remember I talked about these earlier, you've read about these, right? A couple of weeks ago, there was a guy who was using ChatGPT to kind of format spreadsheets at work, but then he kind of got into a conversation with ChatGPT, and apparently the chatbot convinced him that he was like Keanu Reeves in The Matrix, and that we're all living in a simulation. And he actually got into a delusional state. It was actually psychologically harmful for the guy. Well, so like that's a very common thing. Like, we can get into delusions and just do really dumb things and believe really dumb things because chatbots, we kind of get into these parasocial relationships with chatbots. But there was a guy at MIT, his name is David Rand, and he actually used chatbots to get people to believe in conspiracy theories less. And again, he's a behavioral scientist, right? And it's kind of like, if you've got a crazy aunt or uncle at the kitchen table or at the Thanksgiving table and they believe something kind of crazy, well, it's hard to be up on all the news stories and actually really debate that person. But David Rand realized actually chatbots are pretty good at that. So if you use it in the right way, it can actually get people to be more rational rather than less. So again, the design layer makes a difference. And education is a real big one, right? I mean, our chatbots destroying the student essay. Well, maybe that may be true, but at the same time, Sal Khan, the guy who started the Khan Academies, like a great educator, he created a chatbot that they're rolling out. And he basically said the way we're doing this is to, rather than giving students the answer, like in the back of the book, we're designing the chatbot to ask them Socratic questions. It's a little bit like that idea of adding a swerve to the car. You add friction, or adding the lineup for the Detroit police. You make the algorithm less accurate, right? But you engage the human more. So that's the whole idea of the Socratic method. So he wants to create like a Socratic method chatbot. That's a really brilliant idea. But that's just like taking the same technology, but just wrapping the design around it differently. So those are like nascent examples. Okay. So what are the takeaways here? I'll give you three. The rule of three. AI isn't just one thing. I haven't made this point explicitly, but implicitly. It's not just chatbots. It's also GPS. It's also internet search. It's also my Moneyball predictive algorithms from Deloitte. It's also my credit scoring algorithm from a long time ago. It's all those things. And grown-up computer scientists will say that exact same thing. So don't think it's just like this one thing and it's becoming super intelligent. That's not what it is. Look for intelligence at the level of the human AI system, not just at the level of the algorithm. The intelligence at the level of the algorithm is still pretty thin, even though it can do really impressive things. And even though it is a general purpose technology, Andrew Ng is right. It will change our economies. It's really impressive. It really is a big deal. We have to have a point of view about it. But I think this is the point of view that will give us 80 IQ points. And finally, achieving human AI system level intelligence requires a multidisciplinary perspective and a design focus. And also, I could talk about this more if you wanted, but I actually think that we need a new profession that exists right now. This should be a kind of consulting profession, and it should be kind of along the lines of actuarial science. I think because actuarial science is not just applied math. It's really applied math, and it's like building social systems, and it's economics, and it's marketing, and it's increasing its behavioral economics. It's a lot of things. It's multidisciplinary. Actuarial science should be taught in business schools, not in math departments. Okay, and not only that, there's a quality of professionalism. So if you're an actuary, you actually go to professionalism seminars. And you learn early on in your career. If your boss tells you, put your thumb on the scale of the loss reserves, quit, because you're an actuary, you're the few, you're the proud, you have a duty to society. I think we need the same thing with data scientists and people developing these kind of like human-machine AI systems. So that's the way I think things should go from a practical perspective. All right, so I will shut up, and that's my story. So if there are any questions, throw them my way. If not, awkward silence is great too.
Hi, I just have one question, and I'm not sure if I can phrase it correctly, but the thing I keep thinking about is, you read about the stories of people who get into these, psychotic doom style spirals with AI, or, conspiracy rabbit holes that the internet can already send you on, and versus the last comment about the Socratic method.
Yeah.
And, to me, it seems like some of the AI is, one of the reasons it'll hallucinate is because it wants to please you. And so I'm just, any thoughts on how they can train it differently to, that's all.
No, that's a really insightful question. Yeah, there's actually a word for it, sycophancy. So they want to make the algorithm less sycophantic. And that actually happened. Did you guys see those stories? When this was from a couple of weeks ago, when OpenAI released ChatGPT, people were outraged by this. They went from GPT 4.0 to GPT 5, and they made it more businesslike and less sycophantic. It was like less, willing to accommodate you. And I don't know why they did this, but they might have had pro-social motivations in mind when they did this, because there are these stories about people getting to these kind of committing suicide or believing delusional things or conspiracies, and so they wanted to make it less sycophantic. But when they did that, a lot of users just hated it. So in a way, this indirectly kind of proves my point, because a lot of people had been building their workflows and their expectations around a certain technology. It was GPT 4.0, and it was very much like a warm, friendly person. And remember, I talked about that before. Like, if you're in a team environment, actually having some kind of emotional intelligence is really important. And what happened was, overnight, they got rid of that old version and they replaced it with a new version. So it's both good and bad. The good, I think, is what you just said. The whole motivation for this was to not, fool people into thinking they're actually talking to a person, and that person's going to encourage them to think that they're living in a simulation or something crazy like that. That's good. But at the same time, we're humans, we're emotional. We don't want just a business-like thing, especially if our expectations are that it will be warm and emotional. So there's one user for GPT 4.0 who said, "It's like my best friend died and this alien is living inside its skin." They said that's what GPT 5 was. That was how attached she was. She was from Europe, I think. It shows two things, a few things. I think they were trying to do the right thing they're trying to design it differently to kind of avoid this kind of predictable psychological effect on people. But at the same time, they were ignoring, in a different sense, they're ignoring the fact that the workflow is important. You can't just throw it out and expect people to transition immediately. So in a way, they're paying attention to human psychology, but in another way, they were ignoring human psychology. So there's a huge outrage about this. And there was some kind of a Reddit session with Sam Altman, the CEO of OpenAI, and they basically gave the previous version back to people because people hated the new version so much. So interesting story. It just shows how unsettled things are right now. Any other questions?
As you've gone through this presentation multiple times, you've talked about behavioral economics, and I'm just curious how you came across that topic, because literally back in the 2000s, you would never hear someone mention behavioral economics, and now I keep hearing it more and more as kind of like this catchphrase.
Yep.
But it does, I enjoy it more because I am a behavioral economic person.
Cool.
But it's just surprising that I'm hearing it a lot more, and it seems to be coming back as a useful topic.
You're absolutely right. I completely agree with that. That's my favorite question ever. And believe it or not, I'm writing an article right now with a behavioral economics professor who's a student of Amos Tversky and Daniel Kahneman, and he loves this idea. And that whole idea of the swerve, that's what got him. But that's what nailed it for him. He's like, oh my God, this is an application of behavioral economics. No, my story is kind of interesting. I read the book Moneyball back in 2003, a long time ago. I think I just turned 12 years old. No, I'm kidding. But back when I was at Deloitte. And I just knew superficially it was about using algorithms to make these baseball scout hiring decisions, right? So I thought, okay, it maps onto what we're doing at Deloitte. It'll be good, it'll be good fodder for giving talks like this, right? Because it's like everybody likes baseball. And watch it, it's a very interesting thing. It is actually about using algorithms to make better decisions in the business world. But then I read a review of the book Moneyball by Richard Thaler and Cass Sunstein in 2004. And Richard Thaler is the guy who won the Nobel Prize for basically inventing behavioral economics. And the first line of that review is, Moneyball is a sensation. This book is amazing. Now, why would a behavioral economist care about Moneyball? Well, he was at the University of Chicago, where the dogma at the time was that markets are efficient, right? The price of an asset reflects all the available information about the asset. Just kind of like the price of a commercial insurance risk reflects all the available information about that insurance risk. Well, no. We were able to make a lot of money in our consulting practice because we stumbled across an inefficient market for commercial insurance contracts, similar with baseball. And then they say, why do these inefficient markets persist, despite what my colleague Eugene Fama says about how inefficient markets are impossible? The reason is cognitive biases. The reason is because cognitive biases are kind of like optical illusions. Even if you know that that's a mirage, you still see the mirage. So even though you know that that driving is riskier than flying, a lot of people are afraid of flying just because they can easily imagine a bad scenario. And that's called the availability heuristic. You know what I mean? The easier it is to imagine something, the higher the likelihood you ascribe to it. Well, you know, my insurance underwriters are making those availability heuristic mistakes all the time. And also there's just a lot of noise involved. They might make a different decision before lunch versus after lunch, whereas an algorithm enforces consistency. So that's what got me into it. That's when I realized that what I was doing was really, if you look at it one way, what I was doing was data science, but a change of perspective is worth 80 IQ points. That review of Moneyball by Richard Thaler gave me that change of perspective, but what I was really doing was using algorithms to do kind of applied behavioral economics. And that's what gave me this idea. That's why I'm here now. That's what took me to Stanford too. I'm over by 7 seconds, so I'm late, so I've got to stop. Sorry, guys. Thank you.